This lesson is on section 10.4, how to use the perimeter and areas of similar figures to find missing values. So today we're going to compare the perimeter values and the area values for figures that are similar. So this square, we know that all squares are similar figures because they all have congruent angles and their sides would all be the same proportion. If this square has 3 times bigger sides than this one, the first thing you have to do is I want to compare ultimately their perimeters and areas. But the first thing you'd have to do is figure out the side lengths. If the scale factor is 1 to 3, then you would simply take 2 times 3 and get 6 units. That means the length of these sides would have to be 6. So the ratio of their sides would be 2 to 6, or since it says 3 times bigger, you know the ratio of the sides is 1 to 3. Let's look at the perimeters. The perimeter of this square would be 2 plus 2 plus 2 plus 2, so it would be 8 units. The perimeter of this one would be 6 plus 6 plus 6 plus 6. The perimeter of this square would be 24 units. Notice that the ratio of their areas is 8 to 24, or 1 to 3. Notice that the ratio of their sides and the ratio of their perimeters is exactly the same. That's how it should be. The ratio of their sides and the ratio of their perimeters will always be exactly the same with similar figures. The areas are a little bit different. The ratio of their areas, let's see here, the area of this square would be 2 times 2, so the area would be 4, and that would be square units. And the area of this one would be 36. 6 times 6 is 36, so it would be, the area would be 36 square units. Notice that the ratio of their sides is 4 to 36, or 1 to 9 when you put it in simplest form. It's not the same as the ratio of their sides and the ratio of their perimeters. It does, however, relate to them. The relationship is if I take 1 squared, I get 1, and if I take 3 squared, I get 9. The ratio of their perimeters and areas is exactly the same as the ratio of their units. With perimeters, we use single units, and with area, we use square units. Same thing with their ratios. With the ratio of their perimeters, we use the single ratio. With the ratio of their areas, we use the squared of the ratio. So how does this all go together in a general basis? So when you go to determine the ratio of their sides, that will determine the ratio of their perimeters and areas. If the ratio of their sides, for example, is A to B, then the ratio of their perimeters will also be A to B. And then, excuse me, to get the ratio of their areas, you would have to square A and square B. So the ratio of their areas is A squared to B squared. So what kinds of problems are we going to be doing that we're going to need those things? You're going to get questions like this. For example, these 2 triangles are similar. So to find the ratio of their sides, you simply take one to the other. I would use the ones that don't have decimals because that seems to make it easier for students. So I would say that the ratio of their sides is 4 to 5. You can certainly use 6 to 7.5 or 5 to 6.25, but then you'll want to simplify them down to whole numbers. And when you do that, you'll get 4 to 5. So what would the ratio of their perimeters be? Well, it would be exactly the same as the ratio of their sides. If I added these up and added these up, you would get a ratio of, 1115 to 18.75. And when you simplified that down, you would still get 4 to 5. To find the ratio of their areas, you could find the area of this one and find the area of this one and compare them. Or you can use what you know about the ratio of their perimeters. If you square their ratio of perimeters, 16 to 25, that's going to be the ratio of their areas. No, that's not necessarily going to be their areas. It's going to be the ratio of their areas. There's a difference. All right. Another way that we can use this, for example, if you have two similar pentagons, the area of the smaller pentagon is 27.5 square centimeters. They want to know what would the area of the bigger pentagon have to be based on the fact that you know the side lengths. Okay? The ratio of their sides is 4 to 10, which would reduce down to 2 to 5, which tells us then that the ratio of their, this should be areas. The ratio of their areas is 4 to 25 because we square 2 and square 5. So the ratio of their areas would be 4 to 25. We can use the ratio now to find the missing value. We know the ratios of their areas has to be 4 to 25, and we know that the area of the smaller one is 27.5. So we can use that to find the area of the larger one. We simply cross multiply and divide now. So we take 27.5 times 25, and then we divide that by 4, and we would get 171, basically 0.9 when we round. So the area of the larger one would be 171.9 square units, or square centimeters actually. Okay, so you take the ratio of their sides, put it into the ratio of their areas by squaring them, and then use that ratio to find the missing area value. Another example, if I give you the ratio of your areas, can you go backwards to the ratio of the sides? Well, to go from the ratio of the sides to the areas, we square. So if you're going to go backwards, you have to do the opposite of squaring, which is square rooting. Okay? Now, when I take the square root of 192 and the square root of 75, I don't come up with anything good. However, 192 over 75 is not in simplest form. Both of these are divisible by 3. If I put this into simplest form, that gives me 64 over 25. Now when I go to take the square root of them, the ratio becomes much easier. The square root of 64 is 8. The square root of 25 is 5. So the ratio of their sides would be 8 to 5. So the trick here is make sure if you're going backwards that they're in simplest form first. Reduce down the fraction and get it into simplest form before you square root the pieces to get the ratio of their sides. This would also be the ratio of their perimeters. Remember that sides and perimeters have the same ratio. So the ratio of their perimeters would also be 8 to 5. The last one, I don't give you the area, but since it's a 16 by 8 rectangular garden, you can find the area. 8 times 16 is 128 square feet. So that is the area of the smaller garden. They want to know how much it's going to cost for the bigger garden. So I took 12 times 24, and the bigger garden would be 288 square feet. It says the mulch to cover the 128 square foot garden costs $48. So if it's the same rate, how much would it cost for the 288 foot square garden? So we would take 128 for $48, and we would compare that to 288 for how many dollars? So again, we set up the proportion and we cross multiply. We would take 288 times 48, and then we would divide it by 128, and we would get 108, which means it's going to cost them $108 to make the bigger garden as compared to the $48 it would cost them to make the smaller garden. This completes this lesson. Your homework is as follows.